Howdy. All righty. Hello, hello, hello. Where's the rest? People showing up. Can one of you guys put in the WhatsApp chat? Well, I can do that myself. Okay, here we go. More people showing up. Good. So we can, hi Ethan. So we can start slowly. About half the class is here. By now you probably have seen my post in the WhatsApp group regarding the schedule. Why is this so weird crooked? All right, so the AP exam, AP Physics C exams will be on Monday, May 11, 2020, and specifically mechanics will be at 18 o'clock Berlin time, and the E&M exam will be at 20 o'clock Berlin. And I sent you guys the schedule. Let me just double check that's right. 18 and 20 is correct. Eastern time noon and Eastern time 2 is correct for those two exams. Okay, so that means they've moved it forward by 1 week. Okay, they've into the future by 1 week. I'm never always confused when people say we want to move that forward. Like, which direction is that? I think that's confusing. But anyway, so they've moved it into the future, 1 more week into the future. Both of these times are in the evening, which is unusual for us, but I think, yeah. And on here, so if I understand this correctly, there is a late testing date on June 1st. And the makeup test, I don't know what the situation is. I think the implication would be that people are supposed to take this on May 11th. And then if you have a reason why you can't take it until June, then it would be then. Why is it so late? It's so late because they're having everybody do it at the same time. And that requires it to be everywhere the same time in the world. And I think they've picked a time that kind of works. That's a good question about picking the June date. That needs to be clarified. Normally, makeup exams are for people who have a good reason to miss it. Now, of course, everybody has a good reason to miss it at this point. You know what I mean? Because of Corona. But I don't know. I don't know if it's simply an opt-out. I don't want to do it on May 11th. I want to do it on June 1st. I'm not sure, but the way they were written on the schedule that I received, it looks to me like it's not. Oh, Ray, that's a great question. I don't know. They originally said there will be 2 testing dates, and now it looks more like, oh, there's original date and then there's a makeup day. Um, oh, Luai asked if we're at a disadvantage because of the late time. Um, you know what? I don't know. I really, yes, maybe, but everybody's schedule is kind of screwed up. So those Pacific time kids are taking it at 9 o'clock in the morning, and they might say, "Well, we're sleeping till 11 every day." So, meh. Yeah. So they're definitely. I don't know. I do not know the answer to the question of whether you can just opt out of um, of the time and take it on June 1st. I don't have an answer for that yet. So I'm giving you the information as I get it. But the way yeah, I think it depends. The way it was written, it looks to me like we're supposed to take it May 11th, and maybe Ms. Gephardt's going to clarify that, and it could be. Yeah, I really don't know. I mean, and I don't think they necessarily know. I think there might be some options, but for now, again, the situation is fluid. We're going to plan on you taking it on May 11th. So we're going to base all our planning based on that, and then we can always adjust plans later because who knows what exactly goes on. So this is the plan. You're going to take the exams on May 11th, which is from it's a Monday. So on the coming Monday is April 6th, right? So just kind of writing the weeks that are coming up. So let's see, we have April 6th. Then we have April 13th. Then we have April 20th. Then we have April 27th. Then we have May 4th. And then comes the exam. On 5/11. Okay, so that means that between now and then, plus today and the weekend, so we have 3 more days this week, but otherwise, 1, 2, 3, 4, 5 more weeks is where we are. And of course, these 2 are officially spring break, so we shouldn't really count those. Okay, so on the WhatsApp chat, Alex asked about moving the clausur from April 20th to April 27th. Okay, and I think that's a reasonable thing to do, which would leave us with 2 weeks of review for AP Physics C mechanics, which we're still wanting to do. So we do want to have some time to do that. But I think 2 weeks would be fine for reviewing for that. And as we get ready for C mechanics, my intention is to stick with the schedule, which would be 4 periods per week. But if we April 27th. So why don't we do that first? So let's have kind of not a vote, but just an expression of opinion. So moving the clausur to April 27. Why don't you guys just give feedback here? Yes, no, what do you guys think? Sachin asked about how we're going to take the clausur. That's again a moving target. I don't know if we're going to be in school. They've told us that we're going to be back in school in April 20th. And so far, they have not changed that. So right now, we're slated to take it at JFK. And I think we all agree that that's probably not going to happen. So we'll have to do some kind of online clausur or do it on Zoom, or I don't know yet. We have some time though, because we have 1, 2, 3 weeks and 3 days. So in 24 days, we'll do the test, the exam, the clausur, and exactly how we'll do it, we'll figure it out. My intention is to model it as much as possible on what I think the actual clausur, the actual AP exam will look like. And I don't have much more detail for you, and more details will become available as the US wakes up, because they're supposed to post more details today during the workday. What I did here is that you would have 2 questions. I think you guys already knew that. Maybe not. So we'll have 2 questions, and they'll refer obviously to the 2 units. And the plan would be that you would have 20 minutes to complete a problem, and then you'd have 5 minutes to upload it. That's what I think is going to happen. Not absolutely sure yet, but the idea would be that both the clausur and the exam would be 2 times 20-minute FRQs, and then in between, you'd have 5 minutes to upload. So that's what I think it's going to be like, and we'll see as it becomes clear, because they gave a social studies example. I don't think it's from APUSH or something, where this was a similar thing, although they had one 15-minute question, one 25-minute question. I think it's unlikely they would do that based on how the AP Physics C exam is structured generally. I would assume it'd be 2 questions with equal amounts of time, 2 times 20, 5 minutes in between to upload. You would not be able to switch between questions. That's important. So you get question 1, work on that for 20 minutes, upload it, then you get question 2. So you can't go back, which on a normal AP exam you can, because they give you the paper booklet with the 3 questions, and you can say after you do question 2, like, oh crap, I forgot something, you go back. That wouldn't work this time. Okay, so this is the general structure, and my intention is that your clausur would be as similar to the exam experience as I can make it. I don't know exactly what kind of anti-cheating devices they're going to use. They're going to have some kind of, software or website or something that kind of makes it more difficult to cheat, but it won't be necessarily perfectly. It won't be necessarily perfectly cheat-proof, obviously. Okay, good. Those are the details that I have right now to talk about. So we've decided to have our clausur on April 27th. So until that point, we're reviewing E&M. And then after 4/27, for the last 2 weeks, we're going to review mechanics. Okay, and in this period, we can look at having more meeting time if you would like. If you want to switch to 6 periods, for example, we have obviously 6 periods available. Right now, we're meeting for 4:45s a week, but we can also do Doppelstunden if you think it would be helpful for you guys to get more review for mechanics. Then we could do that there as well. But we'll get to it a little after Easter break. Nice thing is we don't have a test now the day we get back, meaning right after break. Obviously, everything during the next 2 weeks is optional. I will still meet with you guys twice a week, and that's again optional. But these sessions have been kind of optional for some of you as well, not to mention any names. But so next 2 weeks, and I opened up the question to you guys. What day would be good? My intention was to do these sessions at 11 o'clock. Is that reasonable? I think, does that seem like a reasonable time? That way I'm done by lunch. And is that like way too early for your spring break sleeping schedule? Does 11 o'clock seem reasonable? We could do 11:30. That'd be good. 11 o'clock seems reasonable. Give a little structure to your day. Give you a reason to get out of bed. Okay, so let's go down here. Okay, so here's the proposal, 11 o'clock. First off, what do you guys think? Is that okay? Yes? No? Give some feedback. What you guys think? Okay, several people said that's good. So can I get more feedback from the other people, please? And please, feel free to speak up and say, yeah, fine, okay. Okay, why? Yes, yes. Any more feedback? Agree? Good, good, good. Okay, so we're gonna do this. 11 o'clock it is, and I'm pretty open. I mean, I can really any of those days are fine for me. Monday, Tuesday. Justine, it's not mandatory. It will be optional. It's optional. Okay, so Monday, Tuesday, Wednesday, Thursday, Friday, 2 sessions is what you guys requested. That's a good question. Monday, Tuesday, Wednesday, Thursday, Friday. And why don't we just do this? Everybody just pick 2 days and then just post it in there. Monday is M, Tuesday is Tuesday, W is W is Wednesday, R for Thursday, and F for Friday. And just write down your 2 favorite days and boom, off we go. We can kind of total them up. Twice a week is the plan. Yes, I'm still going to record them. They're going to run the same way these are running, so I'm still going to do the same thing. Yeah, we can consider that if you want to do. I think I can record from Zoom as well. The question I have, I think you guys are wanting to have an audio stream as well. Let me look into that. I was actually looking into adding a audio stream that we could get like audio. You guys can actually like, what I mean? Something like that, screen record. Okay. Let's figure that out. I only got 4 or 5 of you to say one thing or the other, but it seems that Tuesday, Thursday seems to be what you'd like to do. Okay. Okay. Unless somebody else says something else, we're going to go with Tuesday, Thursday. 1 vote for Monday, half a vote for Friday. Okay, we're going to do it Tuesday and Thursday during spring break, 11 o'clock during the next couple weeks. And there you go. And we'll figure this out, how to do this, whether to do by Zoom or to YouTube with an added audio stream. If we could have like a group chat that's also recorded, then you guys could more easily ask questions or participate. I get that. I think that makes sense. I'm happy to look at that. It must be technologically possible to like call in to a YouTube live stream as well, because really that's the function we're looking for. We're not looking for, with all due respect to all the beautiful people in AP Physics, We're not looking for your images to be in it, but you want to be able to ask questions and respond to questions more easily, right? So Zoom might be overkill, but I get why it would be also a good thing. So let's figure out the technological solution that makes the most sense. As Alex made the proposal, maybe I can make him my lieutenant in this regard to assist me with this decision. Would that be okay, Alex? So you can give me some tech input and like figure out what would be the best way. Okay, good. Okay, Alex and I will get back to you. We'll kind of look at different options and then we'll let you know what's the best option. We will add audio. I get that might be more helpful for you guys in order to make this work better. Okay, so Tuesday and Thursday will be then the AP Physics live stream. I will also offer, and this is open to all my physics students, on 2 days a week, I will offer a astrophysics just enrichment program, mostly for my other classes because they don't have stuff happening. I'm seeing you guys anyway, but I just want to give people the opportunity to check in, have something to do if they want to do something, if they get bored and don't know. But so 2 of these days, probably Monday and Wednesday, I would think. I'll offer an astrophysics live stream on Mondays and Wednesdays, stellar evolution, how do black holes form, red giants, white dwarfs, supernovae, all that kind of stuff that's pretty interesting, I think. And we can learn a little bit about that. Well, I know this stuff, but you can learn about this stuff, and I'll help you understand how stars evolve. And how their lives work, and that's optional. I'll offer to all my students. So there's 140 of you. So maybe 10 will show up. I have no idea. So okay, thank you. Good question, Hannah. Abort on anything Unit 4 and Unit 5 related. I haven't updated those dates. Do not do any work on magnetism right now. Okay, after the exam, we still have school year left. I do want you to learn that stuff. So we will still come back and do Unit 5 specifically because we haven't finished it yet. We never had a quiz on Unit 5 because we don't have to for the exam, but we will come back to Unit 5 after the AP exam. Okay, our school year goes till the end of June. So even if we wait till the late date, June 1st, for nothing new happening until then, I'm not sure if we're going to do that. Either way, we're still going to have time after that to do the unit and finish the unit, and we will do those. So problems for Units 4 and 5 will contribute to your JFKS grade for the course, but the due date I'll push into the future, and I'll push it into June. Okay, so don't worry about that right now. Okay, I'm going to take a picture of this, and good. Let's see where we are. We're at 10 to 2. Yes, there will be a quiz on Unit 5. Cool. Great. So we only have about 21 minutes left, but let's see if we can actually get through. We're on the 2015, and we're doing FRQ number 1. I already started this in class on Wednesday during office hours. 2 capacitor plates, they're separated by a distance d. We have plus q here, minus q there. And of course, this means we've got plus charges up here. We've got minus charges down there. We have electric field pointing downward because it is going from the positive to the negative. We've done this before, and I did it again on Wednesday. We can use a Gaussian surface to find the, that doesn't show up really well. We can do a Gaussian surface to find the electric field in there, okay? And specifically, we can go and say, okay, Gauss's law, here we go. Okay, so let's take a look. The only place we have flux is down here, okay? And therefore, this would be E times the area of the plate, right? And that's equal to Qn, which is just plus Q, divided by epsilon 0. All right, and we can solve that for E and get E is equal to Q divided by epsilon naught times A. Easy enough, okay? And then that's part A. We've completed part A. Now in part B, they've got a completely insane idea, which I love because it's so crazy. What they've done is they put dielectric material in here, and let's kind of show that with a different color. Let's go green, okay? So here's green. So they're putting a dielectric material between these two plates, and the craziness is they're putting right here an axis like that, and they're saying this is 0. Okay. This is D. And they're saying the electric field varies due to the dielectric material, which of course means that the dielectric material needs to be continuously changing, like it's not constant. So we get here the electric field is equal to minus Q over epsilon naught K naught K naught E to the minus X divided by D times A, the whole thing times I. And they're calling this our x-axis. So this is x equals 0 and x equals D. Okay, now you should not freak out here. That's probably the most important thing. And there's a lot of scary stuff in here that might make you really, really afraid. So breathing is a really important part of AP Physics. Now, the magnitude of the electric field we have here is this thing. If we look at the electric field we found, now, first of all, I'm just going to get rid of this crap because that's stupid, right? The magnitude of E, right, is that. Okay, we're just going to call it that so we can compare our two things there. This is comparing with that, okay? Because the minus and the I, all that's doing is getting us scared. The minus means down because the x-axis defined as up, and I vector is a unit vector in the x direction. That's all it is. So removing those just means that's the magnitude of the electric field. Well, let's take a look. The electric field right there is this, okay? And we would have there epsilon naught which is the permittivity of free space, and it's of course replaced by, in this case, the new constant. Okay, epsilon naught is still here, right? Epsilon naught is still here. So in the equation, let's circle the things that are the same. So we have Q, Q. Okay, and we have black. Here we go. Black, this is good. We have A. There's A. So now the last thing that we have here is that we've replaced, let's use purple. Purple's good. We've replaced epsilon naught with this whole shkapui. Okay, and just remembering that when we switch to a material that does not have vacuum or air, we need to replace epsilon 0 with the dielectric constant times epsilon 0, okay? The dielectric constant changes that value effectively, okay? So that means, of course, that in this messy thing right here, this thing is K epsilon 0. Well, what that means is that different color, and specifically brown. That's an interesting change. Okay, specifically that means that this thing right here, that is just hideous. I'm not using that. Green, green. So this part right there, the thing multiplying epsilon 0 is this thing right there. Okay, does that make sense? I did a lot of talking. Just give me a YNM crazy, I don't know, I fell asleep or something at this point, that this is K. Make sense? Okay, cool, great. So another hint for those of us who don't even understand any physics, they're asking for the dielectric constant. And just a reminder that your equation sheet lists all the letters for the different things, right? So there is there the listing that the dielectric constant is K. Is it also in the problem? Oh, it does say the constant K. Well, they give you K0. Well, what does K0 mean? K0 means if you plug in X equals 0. And of course, this thing is equal to 1 if you plug in X equals 0. So this whole thing, you can kind of figure out that whole thing is supposed to be K. So we've got that. K is equal to K0 times e to the minus X over D. Okay, good. And important thing here, they say, and action words are so important. I'm glad we're taking a second to review that. In the problems, they will use different command words, action words for what you're supposed to do. Derive, calculate, determine. Determine is pretty much the weakest because it pretty much is saying, well, figure it out, use logic, use a calculation, use a derivation, use voodoo, whatever you want to do to get that answer, you can pretty much do it. So I didn't look at the key, but I'm assuming that if you write this down, that's full credit. I hope that's true. Okay, yep, correct. Just this answer gives you full credit that's for part B. C, sorry. C? B. Okay. Okay, so part C. Okay, part C. Now, write but do not solve an equation that could be used to determine the potential difference V between the plates of the capacitor. Okay, so all righty, let's kind of not freak out, because when you hear the word differential equation, you guys tend to freak out. So just breathe and remember, okay, we've got to have some kind of equation that has a derivative in it. Okay, so first off, we have electric field. They want us to find the potential. Okay, well, potential is related to electric field, right? Through that the electric field is equal to minus dV dx, okay? In our case, because we're just talking about this direction, right? Times I, in this case. Make sense? Okay? Okay, because we're talking about the x direction here. So minus dV dx times the I vector. Okay, makes sense so far? Oh, yeah. Yeah. So that's a good question, Hannah. And this is, I'm glad you're asking it. So it really, really matters what is on the bottom of the derivative, meaning your electric field is a change of the potential as we move through space. Okay. So electric field exists where there's a change in potential. And the analogy is that electric field is kind of like the slope of an incline. So if you think about an incline, right? So we're higher up here, lower here, and how quickly the potential changes, right, means that's how fast you would accelerate down that hill. So if you're on there with your bike, this slope would give you more acceleration than that slope. Okay, makes sense, because the rate of change of the potential as a function of space is bigger for this than it is for this. Hopefully, both these hills are not changing with time. That could be possible. You could have like a dump truck, right? A dump truck would be moving this. Like you got your sand on here, and then it goes. That would be a changing potential with respect to time. In that case, so this would be dV dt greater than 0, right? DV dt smaller than 0. But we're talking about a change of potential in respect to space, in respect to distance, not in respect to time. Okay, Hannah, does that make sense? And everybody else? Really, really important difference. Okay, you guys still there? You got 12 people. Does somebody say just why for that makes sense? Okay, cool. Great. Now, you might think, oh, cool, we're done. We have a differential equation. No. Okay, a differential equation, you're all good. You're all good. So a differential equation relates something derivative-y to the actual variable. So this is not good enough because here we have e and here we have dv dx. Okay, so we need to actually plug in for e this thing, because this thing has x in it. So if we go now and take that equation, here's this. These markers are working great. I should get myself some more of these. Schneider Max 290. Okay, so specifically, E is this thing. So Q divided by epsilon naught. Hang on, the minus sign is really is important again. There we go. Minus Q over epsilon naught K naught E minus X over D. And then we have an A down here. And on the right side, we have minus dV dx minus dv dx. And of course, there's a minus sign on both sides. So we can cancel out the minus signs, okay? So there's a minus sign there, so we can get rid of those. There we go. Voila. There is the derivative. Hi, Konstantin. So here's the derivative relating it to a function of x. Okay, so this is a differential equation that we don't yet have to solve, which is really important to remember that that first point, or in this case, let me see. Yes, it's 1 point. You can get that 1 point without actually solving the differential equation, which might be tricky. Okay, so at this point, we're in good shape. We've got this thing. We've got our first point. Then in part 2, they're asking to use that expression to actually find the potential difference. Whoop. Okay, so now part 2, basically, you could reformulate that as solve this. Okay, solve this. And again, we could get scared, or we could just say, okay, well, let's do the best we can, and let's see if we can get at least one of the 2 points. So 2 points. C2 is 4 bleeping points. Holy cow. Okay, let's take a look what we got. This thing equals that thing. Now, if we look at that equation, we do on time. We got 4 minutes. Now, I think we've got really 2-3 ways of solving differential equations. Guessing an answer, recognizing an answer, or separation of variables. Those are the 3 things that we can do. Okay. So we've got this thing, and I don't think you recognize right away, like, oh, this is obviously a sine, or this is a cosine, or this is obviously x squared or something. And you also don't have instinctively in your head a solution. Maybe you do, and that's awesome if you do. The third option is separation of variables. Exactly. Good. So we're going to separate the variables, meaning we're going to take this and multiply by dx. And what we're going to do is we're going to make sure all our constants are out front. No need to have those separate. I mean, not to have them all mixed in. So we have q divided by epsilon naught, k naught, and a. There we go. And then we have this thing. And it's 1 divided by this. Well, that's silly because 1 divided by a negative exponential, anything power, is just that positive, right? So I can just rewrite this as e to the x over d. Okay? And then we have the dx over here. And on the right side, we have dv. Okay? You guys cool? Good. So we have this constant thingamajigger here. This is that. We have e to this, we have dx, and we have dv. Okay? Now, because the next step, we need to integrate. So we're going to put an integration sign here. Whoopsie. Sorry. Because this is a constant, we don't have to integrate the constant. We can just leave that there. We can do the integration there, and we can do the integration there. Good. Coolio, everything fine? Okay, cool. And now we can look at this and say, okay, well, how are we integrating this? We're going to go from down here up to there because we'd like to know how much bigger the potential is up here than down here. So we're going to say we're going to integrate this from 0 to d for the x value. And the v value will change from v minus to v plus. Okay? Good. And if you are following along, we are now in possession of 1 point for the differential equation solving thing. Yes, because we're setting ourselves apart from all the, lowly people who can't do this. Because most people will get totally destroyed by this. Just so you know, I mean that as a word of encouragement, that this is very difficult, and most students will suck at this. We are also at the end of time. It's 14:10 at this point. So we will stop there, and we will continue this problem on Monday during our regular. Wait a second. No, we're not doing that. Oh, we are doing that. Tuesdays when we're meeting. Tuesday, 11 o'clock, we're meeting, and I will continue this problem. Okay, and I will continue on the 2015 free response, and then we'll finish that this coming week and keep going on this moving forward into the future. Okay? So have a good weekend. Have a good spring break. If I don't see you next couple of weeks, I'll see you back in class come April 20th. And stay healthy, stay in touch, and get some exercise. Bye-bye.